मैंने उसमें लेसन में क्या किया था, पिछले जो हमारा टॉपिक था, हमने ऑक्सीजन किया, मेथड्स ऑफ प्रिपरेशन ऑक्सीजन के किए, फिर उसकी प्रॉपर्टीज करी, केमिकल प्रॉपर्टीज और फिजिकल प्रॉपर्टीज, एंड देन फाइनली वी डिड द यूजेस ऑफ ऑक्सीजन। अब ऑक्सीजन जो है वो बहुत सारे, बिकॉज ऑफ इट्स हाई रिएक्टिविटी, वो बहुत सारे मेटल्स और नॉन मेटल्स के साथ रिएक्ट करता है, और जिनके साथ भी वो रिएक्ट करके कंपाउंड्स बनाएगा उनको हम क्या बुलाते हैं? दे आर नोन एज ऑक्साइड्स। So basically what are oxides? Oxides, they are compounds of metals and non-metals. Non-metals with oxygen. ठीक है? Compounds of metals and non-metals with oxygen, that is known as oxides. So let's do the classification of oxides. The first type of oxides which we are going to study, they are acidic oxides. Acidic oxides. Acidic oxides कौन से oxides होते हैं? All the oxides in which non-metal is present. So we say that acidic oxides are all non-metallic oxides. Whenever a non-metal that is combining with oxygen to form oxide, that is going to be acidic oxides. Now they dissolve in water. All of these acidic oxides, they are going to dissolve in water to give oxyacids. They are going to form oxyacids once they are dissolved in water. ठीक है? Now they are also therefore, because they are forming क्या कहते हैं उसको, oxyacids over here, and that is the reason why they are known as acidic oxides. ठीक है? Water के अंदर dissolve होके they are going to give us acidic oxides, or they are going to give us oxyacids. That is why they are known as acidic oxides. These are also called acidic anhydrides. They will also be known as acidic anhydrides of their corresponding acids. ठीक है? Now when we are talking of acidic oxides, let's take a few examples over here. Like for example, carbon dioxide. Carbon dioxide को जब हम water में dissolve करते हैं, this is going to give us carbonic acid. So therefore carbon dioxide, it is going to behave as an acid. Similarly, if we are taking sulfur dioxide that is going to dissolve in water to give us sulfurous acid, H2SO3. ठीक है? उसी तरह से अगर हम लोग सल्फर ट्राइऑक्साइड लेंगे, तो सल्फर ट्राइऑक्साइड that is going to dissolve in water to give us sulfuric acid. So all these, they are the oxacids. In addition to this, there are many other acids which are many other acidic oxides which are present. For example, we had done two oxides of phosphorus. One was P4O6. ठीक है? So P4O6 जब dissolve करता है water में, it is going to give us phosphorus acid, which is H3PO4. So यहाँ पे ये आ जाएगा. This is how you can balance the equation. ठीक है? उसी तरह से अगर हम लोग पेंटॉक्साइड ले रहे हैं, P4O10, okay, this is going to give us phosphoric acid. This is the phosphoric acid, right? So all these, they are acidic oxides. Now in addition to these, there are certain metallic oxides also which behave as acidic oxides. For example, we have pinstone, SnO2. Although this is a metallic oxide, still it behaves as an acidic oxide because it dissolves in water to give us stannous acid. So this is one property कि whenever any oxide that is dissolving in water to give us an acid, that is going to behave as an acidic oxide. ठीक है? Same is the case with Mn2O7. Although again this is a metallic oxide, but this is going to react with water to give us an acid HMnO4. And similarly we have chromium trioxide. Chromium trioxide also dissolves in water to give us chromic acid, H2CrO4. So mostly we have seen that the non-metallic oxides, they are going to behave as acidic oxides, but sometimes even the metallic oxides, they behave as acidic oxides, and the examples which we've taken over here is SnO2, Mn2O7 and CrO3. Right? Second type of oxides which we are going to discuss, they are the basic oxides. The next which we have, that is the basic oxides. Mostly the metallic oxides, they are going to behave as basic oxides. ठीक है? यहाँ पे they are known as basic oxides because they dissolve in water to give corresponding bases. They are going to dissolve in water to give us corresponding bases, right? Now, even in case of bases, all those bases which are dissolving in water, they are known as what? They are known as alkalis, right? Just for example, we have sodium hydroxide. Sodium hydroxide has a tendency to dissolve in water. Therefore, they are known as, all those bases which dissolve in water, they are known as alkalis. So it is generally said that all alkalis, they are going to be bases, but all bases are not going to be alkalis. सारे bases dissolve नहीं होते हैं, तो इसलिए सारे bases को हम alkalis नहीं बुलाते, but alkalis जो है वो सारे dissolve होते हैं, they all are bases. So all the alkalis, they are going to behave as bases. ठीक है? Now these oxides, we are saying that they are formed by metals. Therefore, it is said that predominantly they may be ionic, but some of them are also covalent, so they may be ionic or covalent. They may be ionic or covalent. Let's take a few examples over here. We have sodium oxide. When it is going to react in water, ये हमें दे देगा NaOH. ठीक है? Similarly, we have calcium oxide. This is going to give us calcium hydroxide. Similarly, we have copper oxide. Now, copper oxide is going to, it does not dissolve in water very effectively. Therefore, इसकी जो basicity है, वो हम लोग बोल सकते हैं कि this reacts with acid to give us salt and water. So this is undergoing, salt and water, because this is undergoing neutralization reaction. Therefore, CuO over here, that is going to behave as a base. Same is the case with barium oxide. It reacts with HCl to give us salt plus water, BaCl2 plus water. ठीक है? So this is what basic oxides are. फिर उसके बाद third type of oxides which we will discuss. They are known as neutral oxides. ठीक है? Neutral oxides वो oxides होते हैं which react with neither acids nor bases. They will not convert blue litmus to red, neither will they convert red litmus to blue. So these are neutral oxides, and there are a few oxides which are present. For example, we have NO, nitric oxide, that is neutral. Then we have CO, water, and N2O. So these are a few neutral oxides which are present, which neither react as bases nor they react as acids. ठीक है? तो ना वो blue litmus को red करेंगे, ना ही वो red litmus को blue करेंगे. The third type of oxides which we have, they are amphoteric oxides. The fourth oxide They are known as amphoteric oxides. Amphoteric oxides behave as both acids and bases. They are going to behave as both acids and bases, right? Examples which we have is both acids and bases, मतलब ये base के साथ भी react करेंगे और acids के साथ भी react करेंगे. So let's take a few examples. We are taking the example of ZNO. Let's take a base over here. Right? Now zinc oxide is going to react with this to give us sodium zincate, Na2ZNO2. Okay? And plus it is going to give water. So this is again giving the neutralization reaction. If this is the base, this is going to behave as an acid over here. Similarly, if we are reacting zinc oxide with an acid, let's say we are reacting it with 2HCl. So it is going to give us again salt plus water. So it is behaving as an acid over here and it is behaving as a base over here. So that is why it is said to be amphoteric in nature. Another example which we have is that of Al2O3, alumina. Alumina will react with NaOH to give us sodium aluminate, NaAlO2. And plus it is going to give us water. Okay? So it is giving us balance equation. 2 2s are 4 we have and plus H2O. One oxygen is less, na? No, balanced. So there are 5 oxygens here and 5 oxygen on this side. So it is going to give us sodium aluminate plus water. Then if it is reacting with an acid, so again it is giving us salt plus water. So another examples which we can take of amphoteric oxides are like we are taking beryllium oxide. This is an amphoteric oxide. फिर उसके बाद we have antimony oxide, Sb2O3. Then we have chromium trioxide. Then we have PbO, lead oxide, and finally we have PbO2. So these are a few examples of amphoteric oxides. Okay? So amphoteric oxides are going to behave as both acids as well as bases. Then we have next, which are known as compound oxides. Compound oxides or mixed oxides. Compound oxides or mixed oxides. Compound oxides या mixed oxides कौन से होते हैं? They behave as a mixture of two different oxides. Okay, so they are going to behave as mixture of two different oxides. Like for example, if we are taking Pb3O4, so Pb3O4, that is going to be a mixture of PbO and PbO2. Okay, then we have Fe3O4. Fe3O4 is a mixture of FeO plus Fe2O3. Right? Then we have Mn3O4. Mn3O4, that is a mixture of MnO and MnO2. MnO and MnO2. So these are known as mixed oxides, in which one oxide, that is a mixture of two oxides, right? Next we have is peroxides. The sixth one we have peroxides. Peroxides क्या होता है? These are oxides when treated with dilute acids form hydrogen peroxide. So whenever oxides plus dilute acids forms hydrogen peroxide, they are known as peroxides. Like for example, we have Na2O2. Na2O2 को जब हम लोग dilute H2SO4 के साथ react करेंगे, this is going to give us Na2SO4 plus H2O2. Okay, so this is going to be a peroxide. Similarly, if we are taking BaO2 and we are reacting it with dilute H2SO4, this is going to give us barium sulfate plus H2O2. Therefore, this is also going to be a peroxide. Another examples which we can take over here is that of K2O2. K2O2 will react with dilute H2SO4 to give us K2SO4 plus H2O2. ठीक है? The next type of oxides which we have, they are known as dioxides. So this is the seventh type of oxide which we are discussing over here. They are known as dioxides. अब dioxides क्या होते हैं? They contain excess of oxygen, but they do not form H2O2. Right? So dioxides, they are going to contain excess of O2, but do not form H2O2. ठीक है? Examples जो हम लोग ले सकते हैं इसके, like we have PbO2 and MnO2, lead dioxide and manganese dioxide, etc. Okay, so let's see how they're going to react with acids. When they are reacting with acids, like if we are reacting MnO2 with HCl, it is going to give us MnCl2 plus Cl2 plus plus 2H2O. So you can see over here that it is not forming a peroxide. If it is not forming a peroxide, it is not going to hydrogen peroxide. It is not going to be a peroxide. But this is what it is forming. It's a dioxide. ठीक है? Next हमारे पास आते हैं sub oxides. Suboxides. Now, what is a suboxide? Suboxide, they have less oxygen than expected from normal. Sub means less, na? So they are going to have less oxygen than expected. जैसे for example, we have carbon monoxide. So carbon monoxide is having less oxygen. Okay, another example which we can take over here is C2O3, carbon suboxide. C2O3, this is known as carbon suboxide. Then we have Pb2O, that is lead suboxide. And then we have N2O, which is nitrous oxide. So this is also a suboxide. So they have less oxygen than expected. The next we have is superoxides, the last oxides. Ninth, they are known as superoxides. Superoxides, they contain the ion O2 negative. Right? They contain the ion O2 negative, and these are examples which we can take over here is potassium superoxide KO2, then we have rubidium, and we have cesium. Is it clear? So ये क्या करते हैं, जैसे फॉर एग्जाम्पल हम लोग KO2 ले रहे हैं और इसको हम रिएक्ट कर रहे हैं विद वाटर. This is going to give us potassium hydroxide plus H2O2 plus oxygen. Okay, so this is what superoxide is, and this is the classification of oxides. Let's go on to the allotrope of oxygen, which is ozone. We had discussed about ozone initially, so let's discuss it in detail now. So we are going to the first allotrope, which is ozone. Ozone means bad smell. Ozone has a very typical kind of a foul smell. So that is the name which was given, and ozone was discovered by Sorret. Sorret was the scientist who discovered ozone, and he also established and proposed the formula for ozone as O3. ठीक है? Now basically where is ozone present? It is present in sufficient amounts in the atmosphere at higher altitudes. Atmosphere at higher altitudes, approximately 12 to 15 miles away from the Earth's surface. Right? It is approximately 12 to 15 miles away from the Earth's surface. So higher atmosphere where it is present. Now it is formed from oxygen because it is an allotrope of oxygen, as we had discussed. So it is going to be formed from oxygen under the influence of UV radiation from the sun. Okay. Now near the Earth's surface, it is decomposed by dust particles. So when we are going to the higher altitude over here, at the higher altitudes, ozone is going to be present. But when it comes near to the surface of the Earth, it gets decomposed into oxygen by the dust particles which are present on the Earth's atmosphere. Okay? Let's go on to the preparation. Laboratory preparation of ozone. Ozone, it is generally obtained by passing electric discharge over oxygen. So when we are passing an electric discharge over here, oxygen that is going to dissociate into its atomic forms, and oxygen will, one of the atomic forms will react with oxygen to give us ozone. ठीक है? So basically it is seen that oxygen that can be converted in presence of energy which is obtained from the electric discharge, the reaction over here is going to be reversible to form ozone. Okay, now the mixture which we have over here, that consists of 5 to 10% ozone by volume. Okay, and the mixture that is going to be known as ozonized oxygen. The mixture is known as ozonized oxygen, and the apparatus which is used to prepare this, it is known as ozonizer. It is going to be known as ozonizer, right? And there are two types of ozonizers which are generally used. We need not do it in detail, but just for your information. The first one that is known as Siemens ozonizer, and the second type of ozonizer, it is known as Brody's ozonizer. Brody's ozonizer. ठीक है? Now, whenever we have manufactured ozone over here, we say that ozone, it is consisting of a mixture of ozone and oxygen. So how do we get pure ozone from here? Let's see recovery of pure ozone. Recovery of pure ozone from ozonized oxygen. Because what we have formed over here, that is going to be ozonized oxygen. तो उससे हम लोग किस तरह से recover करेंगे? Ozonized oxygen that is passed through a spiral cooled by liquid air. Okay, and ozone condenses as its condensation temperature that is equal to minus 112.4 degrees centigrade. So what are we doing over here is that we are passing the ozonized ozone, okay, ozonized ozone which is ozonized oxygen which is formed over here, we are passing it through coils, through spirals, in which the temperature that is going to be lowered. Now when the temperature will be lowered, we are going to get the ozone. Now this is a liquid which is formed over here. We have condensed the gas into the liquid form, and henceforth we do the distillation of the liquid in order to get ozone. Right? Let's go on to the properties. First is physical properties of ozone. Number one, it is a pale blue gas with a characteristic smell. As we just said that ozone means bad odor, so it has a characteristic smell. Then it can be liquefied to a pale blue liquid at minus 112 degrees Celsius. Okay, it is going to be liquefied at minus 112 degrees Celsius. It is going to be heavier than air. It is going to be heavier than air, and it is slightly soluble in water. It is very sparingly soluble in water. It is sparingly soluble in water, but it is more soluble in turpentine oil. Right? It is going to be sparingly soluble in water, but it is more soluble in turpentine oil, acetic acid or CCl4. So organic solvents may, it is going to be more soluble. And finally, ozone is diamagnetic in nature in comparison to oxygen, which is paramagnetic. Okay? So these are the physical properties. Let's go on to the chemical properties of ozone. Chemical properties of ozone. Number one, ozone is unstable and it decomposes to oxygen when heated. The reaction over here is exothermic, and 68 kilocalories of heat that is going to be evolved. Okay? Then number two, in this case there are certain, इसी वाली reaction में there are certain catalysts which are used. For example, manganese dioxide, platinum, platinum black, ठीक है? फिर then we have silver, lead dioxide. They may be used as catalyst for the above reaction. Then number 2, it has oxidizing nature. This oxidizing nature of ozone is due to its decomposition into oxygen and ozone, into oxygen and nascent oxygen. So it is because of this nascent oxygen that it is going to behave as an oxidizing agent. So let's just discuss a few of the oxidizing agents, oxidizing reactions. For example, HCl is converted to chlorine, right? Now if you're looking at the oxidation number of chlorine in this case, that is going to be -1. So यहाँ पे 0 हो गई. Increase in oxidation number, that is oxidation. ठीक है? So यहाँ पे what are going to be the reaction? We have ozone, which decomposes into oxygen plus nascent oxygen. HCl that will react with ozone to give us Cl2 plus H2O. And what will be the overall reaction? This and this gets cancelled. Okay? And we are going to get what? HCl, 2HCl plus ozone to give oxygen plus chlorine plus water. Okay? In a similar manner, we convert potassium iodide to iodine. 2Ki to again ओजोन की रिएक्शन हो जाएगी, ऑक्सीजन प्लस ओजोन, O2 प्लस नेसेंट ऑक्सीजन. ठीक है? फिर यहाँ पे जो पोटेशियम आयोडाइड है, that is going to react in presence of water. So we have H2O plus Ki plus oxygen. ठीक है? And this is going to give us 2KOH plus I2. So let's see the overall reaction over here. Oxygen and oxygen will cancel out, and we have ozone plus water plus potassium iodide to give us KOH plus iodine. ठीक है? In a similar manner, we can convert PBS to PbSO4. PBS to PbSO4. So we have ozone to oxygen and nascent oxygen over here. ठीक है? और फिर उसके बाद you can convert it into lead sulfate by reacting PbSO4. In order to balance the equation, you need to multiply this equation by 4. Okay? So यहाँ पे again this and this is going to be cancelled. So we have ozone plus PbS to give oxygen 4O2 plus PbSO4. Right? So these are a few oxidizing this thing. अब यहाँ पे एक और क्वेश्चन हमको आता है that what do we understand by tailing of mercury? Tailing of mercury is another chemical property of ozone. Tailing of mercury. In this case, mercury when present in presence of ozone, that is going to get oxidized to suboxide. Right? So mercury will get oxidized to suboxide, which dissolves in mercury. Now this mercury will start sticking to the glass and loses its mobility. We know that whenever we put mercury in any glass, it does not stick to the glass. That is the reason why it can move so frequently, isn't it? So it starts sticking to the glass and it loses its mobility. Therefore, mercury loses the meniscus. And this is known as tailing of mercury. You know the characteristic of mercury, that mercury has a tendency to not stick to the glass. That is why whenever we place mercury in an inverted tube, it takes the upper meniscus. Okay? Now when this is reacted with ozone, the mercury will start sticking to the glass tube and it loses this meniscus. Because it is losing this meniscus, it will start moving. And this movement of mercury in presence of ozone, that is known as tailing of mercury. Okay? Then the next property which we are going to discuss over here, that is bleaching property. Bleaching property. Bleaching means to render anything colorless. Okay. Now it bleaches because of the nascent oxygen which it is giving. So we have ozone to give us oxygen plus nascent oxygen. Now when this nascent oxygen that comes in contact with the colorful material or the colored substance, plus oxygen, this is going to give us a colorless substance. Now ozone that is used for bleaching oil, it can bleach oil, it can bleach ivory, it can bleach flour, okay? And then it can also bleach waxes. So these are the properties. Let's go on to the uses of ozone. Uses of ozone. Now when we are doing the uses of ozone, it is used as a germicide, disinfectant, for sterilizing water, right? For sterilizing water. Then number 2, it is used as a bleaching agent, as we just discussed. It is used as a bleaching agent. Number 3, it is used in the manufacture of artificial silk. It is used in the manufacture of artificial silk. Then number 4, it is used for detecting position of double bond in any organic compound by the process of ozonolysis. So ozonolysis is a process for detection of a double bond. Okay? And then it is also used in destroying odors in crowded places. It so happens that in crowded places, because the oxygen जो होती है वो कम हो जाती है, there is going to be less of oxygen in crowded places. For that, there is a stream of ozone which is, you can say, discharged in that particular crowded place. That ozone is going to dissociate into oxygen and nascent oxygen. और ये oxygen supply जो है ये क्या बोलते हैं उसको? This is given in any crowded places, and as a result of which this can be used as what? As an agent which can supply oxygen. As far as destroying of odors is concerned over here, that it is used in destroying odors in big cold storages. then also in kitchen में जो गंदी तड़के वड़के की स्मेल आने लग जाती है उसके लिए भी ओजोन को यूज करा जाता है. It is also used in hotels and it is also used in slaughterhouses. Slaughterhouses क्या होते हैं? जहाँ पे चॉप होता है, ठीक है, किसका? बकरे का, right? So next we come to structure of ozone. Structure of ozone. When we looking at the structure of ozone, ozone is doubly bonded and singly bonded like this, right? So we have that the bond angle in this case it is 116.8 degrees and the bond length that is going to be 1.278 angstrom. It is a resonating structure, resonance hybrid of the following two resonating structures. ठीक है? This is the first one in which there are 4 electrons over here, 2 here and 6 here, right? और इसका जो resonating structure होगा and 4. Okay? Now what are the tests for ozone? How do we do the detection of ozone? Test for ozone. Number 1, we already know that it has a bad smell. ठीक है? Number 2, tailing of mercury. So we are reacting ozone with mercury. The tailing of mercury is going to be a test for ozone. Number 3, it turns alcoholic solution of benzene brown. It is going to turn alcoholic solution of benzene brown. ठीक है? And it turns starch iodine paper blue. Starch iodine paper blue. So today we are going to do only till here. Tomorrow we are going to finish group 16. We will start with sulfur and then we will go on to the allotropes of sulfur, then sulfur dioxide and finally H2SO4 sulfuric acid.